Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do a very important lead code medium problem, longest increasing subsequence, and I have decided to break this video in two parts. In the first part, I'm going to discuss the brute force solution and an accepted solution for this problem. And in the second part, I'm going to show the optimal solution. But the thing is, the optimal solution is really difficult to achieve and it's a little bit tricky to come up with. So let's understand the problem statement. Basically, we are given an array of numbers and we need to find the length of longest strictly increasing subsequence. So subsequence means that suppose we are given an input like this, 1 2 4 5. So we can say that the value 2 and 5 is actually a subsequence of this given initial problem. Let's try to understand that what is the input given. So we are given over here and 18, and this example, and if we take these numbers 2 3 7 and 101, this would be our longest increasing subsequence. So if we get rid of this value 5, this would be the longest subsequence we can make, where all the values are in increasing order and the length of all the values would be 4, which is what we need to return as a part of this output. So once we know the problem statement, let's see that what could be the brute force approach. So in the brute force approach, we are simply going to take every single subsequence that we can possibly make, keep a parameter that tracks the length of any subsequence, and eventually at the end we should be able to find a subsequence with the maximum length. So let's take a small example and see that what are the possible subsequences we can make. So suppose our given input is 5, 3 and 8. I'm only taking 3 elements because I need to show that why this approach is bad and what are the possible subsequences we can make out of this. So let's start making all the possible subsequences. The possible subsequence would be 5, 5, 3, 5, 8, 3, 3, 8, 8 and 5, 3, 8. These are the possible subsequences we can make out of only these given 3 problems. And if we check the length of each of them, and if we find out the property that which one is a strictly increasing order, we found that this is the strictly increasing order and the maximum length we can achieve is 2. So this solution works, it works fine. The problem is that notice that we are only given 3 elements over here, and based on this 3 elements we were able to make almost 7 subsequences. Mathematically it's actually 2 to the power of 3 minus 1, and for any single given n, this is the number of subsequences we can make. So suppose we are given n values in the given input, the number of subsequences we would be able to make would be 2 to the power of n minus 1. So if we calculate the time complexity, we can just say that the time complexity is actually big O of 2 to the power of n, which is extremely horrendous time complexity, and this is exponential. So even with enough numbers, even NASA won't be able to solve this one. So let's move on to the next approach. Now we want to find the better approach, and we know that the way to do is to use dynamic programming. But the thing is, how can we identify that we need to find the solution using dynamic programming? Also, what dynamic programming solution are we going to use? So I'll be discussing both the things in next portion. And first of all, let's take an example. We'll try to see how we are going to solve it. Then I'll show you how we can determine that we are using the dynamic programming, and after that we would be implying the result, and I would be showing you the coding example. Suppose our given input is, suppose this is the input given, and we need to find the longest increasing substring. So just by looking at the given example, we can determine that the longest increasing substring actually exists between 7, 8, 16 and 27. And now let's see that how can we come up with this solution. How do we determine that this is dynamic programming? Suppose we are just given an example like this. We are just given one value, that, let's say the value is 7. If we are only given 7, what is the longest increasing substring we can make? Well, the answer is quite simple. We can simply make just one substring of length 1. So this actually becomes our base case, that if we are only given one value, we are guaranteed to have at least one substring that would be the longest increasing substring that we can make. So now let's see that how can we use this logic. Say that for all the given elements, basically there exists one substring at least that is the longest increasing substring. Let's just mark all the values as 1. We know that if we are only given the value 10, the longest increasing substring we can make would only be 1. But when it comes to the second value, now we have something to compare to. Suppose the 7 value, if this was greater than 10 and we only had 2 values, we can say that at the second position, the longest increasing substring that we would be able to make would actually be whatever we have made so far plus 1. So we would have been made 2, but over here that's not the case, and over here the value 7 is actually less than whatever we are given the value before that, which means that the longest substring we have at the value 7 would also be 1. So this would be true in this case. But now when we come to 8, we have two possibilities. What are the total substrings we can make up until this point, up until 8? Okay, so for this value 8, what is the one thing that we can determine? We can basically determine that there are 3 possibilities of the substrings we can have and we can compute. One possibility is we could have a substring like 10 and 8. Second one is we could have substring 7 and 8, and third one is we could have a substring 8 by itself in case if all the values before 8 are actually greater than 8. So in this scenario from 10 to 8, we know that 10 is already greater than 8, so we cannot create a substring over here. So let's ignore this scenario. For the second scenario, 7 to 8, actually this is a valid increasing substring because 7 is less than 8 and it comes after it. So what we can determine is that the longest increasing substring we can make at value number 8 would be whatever the longest increasing substring we have made up until this point. So whatever the longest increasing substring we have made for the value number 7 plus 1, because 8 is coming after 7 and 8 is just one step after it. So we can say that longest increasing substring at value number 8 would actually be whatever we have found up until longest for the longest increasing substring of 7 plus 1. And this is how we can determine that this should be solved as a dynamic programming problem, because in dynamic programming, basically whatever calculations we make in the past, we keep track of them in some way, either through an array or storing them in variable somehow, and based on those results we actually use it in upcoming future calculations, so that we don't have to calculate everything from the scratch. So this is one way we can determine that this problem should be solved using dynamic programming, because if we just look at the problem, we understand that we need to find the longest increasing substring, which means that we need to keep track of whatever we have calculated so far in the past, and using those results we would make decisions that whether we want to keep this current value or we want to ignore this current value. So this is a very important thing to keep in mind, and this is basically the core concept of finding the pattern whenever you are given that whether the problem is dynamic programming problem or not. Because in the interview, the interviewer is not going to tell you that hey, this is a dynamic programming problem and just go and solve in that manner. So now let's again continue with our example. So we can determine that currently the value at 8, the longest increasing substring we could make at value number 8 is 1, but we just found that from 7 to 8 we can actually make a substring as well. So this would become actually 2. And we can say that up until the point of 8, the longest increasing substring we can make is actually 2 and not 1. Now let's move forward. Now let's consider for value number 5. At value number 5, let's again compare from 10 to 5. We cannot do anything because 10 is already greater than 5, so there is no point of doing this conversation. Let's compare 7 to 5. From 7 to 5 we cannot do anything because 7 is greater than 5 and also 8 is greater than 5. So at value number 5 there are no values that are less than 5. So the at value number 5 the longest increasing substring we can make is actually size 1, because there does not exist a smaller number before 5 in our given input. So we'll keep this 1 as it is because we have already made all the calculations. Now let's calculate for this value number 16. And actually for value number 16, if you notice that all the values are smaller, so this would be a very good point for us to understand that how everything works. So from 10 to 16, we notice that 10 is smaller than 16, so there is a possibility. And basically we can say that whatever the longest increasing substring we have found at 10, if we do it plus 1, that would become 16. So the longest increasing substring for 10 we have found is actually 1. So 1 plus 1 equals to 2. So let's just update the value 2 over here. And now let's move on with our calculation. So we are done with this 10. Let's calculate with 7. So if we do 7 to 16, actually again we will do 1 plus 1 because LIS of 7. So 1 plus 1 is again 2. We already have 2, so there is no point in updating the value. Let's ignore this. Let's do again with the value 8. So from 8 to 16, we know that the value of 8 is actually 2. So over here at value number 16, we can say that it's increasing substring at value number 8 plus 1. So it becomes 2 plus 1, and 2 plus 1. Okay, I made a mistake. I think this is 1 that represents 5, and the value for 16 is actually over here. So I'll just write it down. So LIS of 8 plus 1 is actually 2 plus 1, which is 3, which is greater than whatever the longest increasing substring we have so far. So which means we can update this value. So over here the longest we have found so far is actually 3. And now we can also create one more substring from 5 to 16. If we calculate from 5 to 16, we found that the value is actually 1 plus 1 would be 2, which is not greater than whatever we have at 16. So we can say that up until this point 16, the longest substring out of all of these values we can make is actually 3 for the values up until the point of 16. And let's move forward with our calculation. So again the next value is 27. 27 is greater than all the other values. So if we do 10 plus 20, 10 to 27, we would find the value as 2. We'll do 7 to 27, we will find the value as 1 plus 1, again 2. We will do 8 to 27, we would find the value 2 plus 1 as 3. Again we will do 5 to 27, the value we would find would be 2. And at the end we would do 16 to 27, and we know that the value at 16 is 3, so we would be able to find the value as 3 plus 1. And because we have calculated all these results, we don't have to do calculations all the way from beginning, and we are just able to use the results we have stored so far. So we know that the maximum value we can find is 3 plus 1. So we would update the value at longest increasing substring at value number 27 to 4. And then we come to our last value 9. So and again we will do the whole thing for 9. So 10 is greater than 9, so we cannot do anything. 7 is less than 9, so we can for this one we can have the value as 2. 8 is also less than 9, so from 8 to 9 value we can have would be 3. 5 is also less than 9, so from 5 to 9 the value we would have would be 1 plus 2, 2. from 16 to 9 we cannot do anything because 16 is greater than 9, and from 27 to 9 we cannot do anything because 27 is definitely greater than 9, which means that the maximum value we could have find so far over here for 9 is actually 3, and that comes from the 8 plus 1. So we will update the value over here as 3, and now we just need to find that what is the maximum value we have found in this array that we have created based on the calculation. So basically clearly we can see that this value 4 is the maximum value we have found, and that would be our answer. That is what we would be returning as longest increasing substring. The thing is, we actually don't need to iterate over the entire array again. We could have actually done this when we are calculating or when we are making this array. We could have just keep track of one parameter called max, and we would compare it with whatever the value we calculate at each location. So whenever we find a new maximum value, we'll just store it in this value, and at the end of our loop, in this max parameter should have our final solution, and we can definitely return this, and this solution would work perfectly fine. Now let's calculate the time complexity. So basically the time complexity for this one would be big O of n square, and it's pretty simple to understand that, because for every single element we are basically taking all the elements before that and comparing it with whatever the element we have. We did the same for every single element. So for n element n, we might have to compare it with n minus 1 values. So the time complexity becomes big O of n square. And if we calculate the space complexity is also big O of n, because we need to create this additional array to store all the values. And this is a good time complexity and good space complexity compared to our brute force approach. Remember our brute force approach, the value we had was actually 2 to the power of n, which was way higher. This was almost exponential time complexity, and we have done significant improvements from this one, and we have actually moved to n square. So this solution would work perfectly fine in any interview. And I'll move on to coding, but the thing is, I would be making another video to explain that how can we solve the same problem using nLogn complexity. And this is actually pretty ideal, and if you can achieve this in any interview, if you can come up with this time complexity right then and there in an interview, you can be guaranteed that you would be placed in any company you want. So let's move on to coding now. So first of all, we will create a new array called lis, and we would create the array of size, whatever the size we are given for the input nums. And we will initialize the array with value 1. We will also create a parameter called max that will keep track of the maximum longest increasing subsequence inside the loop, and we will initialize the value as 1. So now let's create our two loops. So first of all, we will create a loop that is starting at position number 1, not 0, because we need something to compare to, otherwise all the values would be just 1 before that. And we will run it till the length of the given array. Well, now this would be our inner loop, and we would start it from position 0, and we will run it all the way up to the position I. Now inside the loop, first we need to determine that whether our current I, that is on the right side of the array, is actually actually greater value than whatever our j is. If that is the case, then only we would move forward with the calculation. So if I is greater than j, Now we will do our calculation for the dynamic programming. So the value of I would actually be the maximum value we can achieve for whatever LIS of I we already have, or 1 plus whatever LIS of J we have achieved. And this would be our recurrence relation. I guess that is what it is called in dynamic programming. So this is just to keep in mind that yeah, if you mention that this is the recurrence relation, it sounds really good impression. It sounds cool as well. And also we check that whether the current LIS value is our max or not. So we'll just check the existing max value with the new LIS that we just created. And yeah, I think that's pretty much it. After this loop runs, we can simply return whatever we have found for the value max, and this should be our answer. Let's try to run the code. I think we made some silly mistake. Yeah, yeah, looks like our code is working. Let's try to submit it. And our submission works, but if you notice that our submission is not actually the best submission, it's only faster than 55.54% of the online submissions, and that is because our this solution is actually work in big O of n square times, so n to the power 2. But there is another solution that actually runs in big O of n log n time, and I would be creating a new video explaining that solution. And this is actually a pretty interesting solution. It's actually a sorting algorithm that we are going to use to achieve this. So hope you like the video. Let me know what do you think, and if you have any suggestions, just feel free to reach out to me. Our goal is to get employed in any FAANG company, and until we get there we are not gonna stop. So hope you like it. Thank you.